Hello everyone. Today we want to talk to you a little bit about requirements. So why do we need requirements? What's important about having organized rules and kind of like things that we know the project is going to accomplish? Because if we don't have requirements, we end up with a variety of different opinions, all contributing to supposedly what we're supposed to build. And those opinions can definitely be at odds. Whether the stakeholder be, even if the stakeholder is very clear about what they want in words, we don't organize that information and write it down, we might end up with a roller coaster when all we really want is a tire swing.
So engineering requirements align pretty well with requirements of clear, objective engineering communications. For example, a customer may come to you with a desire for a design feature, but that desire has been expressed in a rather vague and broad way. Our job, your job as the engineer, is to turn that requirement into something that is verifiable, and that means that you can measure it and test it for whether or not it has met that requirement. It's unambiguous, meaning there is a precise and clear measure to that requirement. That it is abstract, meaning rather than describing the internal workings of the design, you're describing the functionality of the design, and it must also be traceable back to the requirement presented by the stakeholder or client.
So let's take a little more in-depth look at a couple of these properties of an engineering requirement. So verifiable. As Rachel mentioned, it needs to be measurable. If your engineering requirement is written in such a way that you can't evaluate it we can't agree that it's been properly evaluated. That's what I wanted to say. It's not going to be considered verifiable. So, for example, the system will be cooler than a Tesla Model 3. I would argue that my version of cooler and what I think is cooler is probably different than yours. On the other hand, you could make an engineering requirement that is, the system will be rated as cooler than a Tesla Model 3 by 9 out of 10 people. You could find 10 people, you could have them rate it, and I can't argue with that. So we now have created an engineering requirement that is verifiable. This type of engineering requirement is something that I call a user survey. It is possible you will need to have something like this for your system. Anything that's an aesthetic choice, you're going to have to verify with people. So this is an example of how you could do that. You should not make all of your requirements be verified by people. They should actually, the majority of them should be measurable by testing equipment. Another example, a bad example, is the system will travel faster than the average human on flat terrain. What is average? What is flat terrain? So we can revise that to the system will travel faster than 2 miles per hour on flat level asphalt. We're dealing with unambiguous. So this is to make sure that we can't interpret it in more than one way. And unambiguous and verifiable kind of go together in many respects, because if it's not verifiable, it's usually because it's also ambiguous. So in this example, the system will operate normally without failing. What is normally? What is without failing? So you can see there's a good example below for that. The system will transmit measurements immediately to the server. Well, unless we're using quantum mechanics and we have instantaneous transmission of data, we know that's not even possible. So a better example would be the measurements will be recorded by the server within 100 milliseconds. Abstract. So tell us what the system does, not how it does it. This is a very common mistake because as engineers, we tend to start focusing on what we know and how we can get it done. And that's great, and you should do that. But if you make a system requirement, so an engineering requirement that is part of what the system must do, and within that you specify an internal component, if you then decide that internal component is not going to work, you can never meet the requirement. So that's an important thing to realize. So for example, the system will use lithium polymer batteries to have a runtime of greater than 24 hours. Awesome. Why did you include LiPo? Drop that out and just talk about what the system does. Another one that I commonly see is the system will use a buck converter to produce 5 volts for the microcontroller to run on. That's all internal. There is no external interface that the customer cares about in that requirement. So wipe that one and start over. The exception of this would be if maybe your system was supposed to produce a 5 volt output for the rest of the world. You could argue that this might be a better fit, but even then, specifying it's a buck converter is not necessary. Finally, traceable. So for us in this ECE Senior Design course, we've built traceability into how you enter your requirements. So when you go and you enter your requirements into the web form, it requires you to enter both the customer requirement and the engineering requirement at the same time, therefore showing the traceability between the two. A little bit about requirement categories. Requirements can come from a variety of sources, including performance, operational, political issues, whether or not the system's maintainable, whether or not it's legal to build. So these categories are things that we should be aware of when we're actually producing our requirements. A good set of requirements will have requirements from all categories. So let's look at an example.
So one example of a customer requirement would be that the system must be small. As you can tell, it's somewhat difficult to measure whether or not a system is small. The word small is rather subjective rather than objective. Therefore, it's difficult to measure, difficult or impossible to verify. So what needs to happen with that particular requirement is that it needs to be made more precise. You might add specific dimensions, for example. The system must be less than 10 centimeters by 10 centimeters by 10 centimeters. That is measurable. So it's objective.
But what about the category? So where does this requirement come from? If we go back and look from before, we have a list of categories. So is this a performance category requirement? Is this manufacturability? Is this reliability, usability? Odds are you could say that this falls into multiple categories. It could be usability because the system has to be man portable, so it needs to be small in that respect. It could be based upon environmental because it uses less materials. It could be based upon performance because it's just a function of how well the system would work to be that smaller 10 by 10 by 10 centimeter size. So think about your categories as well. And most customer requirements can generate engineering requirements for most of the categories. Let's look at another example though. So the system should have high quality audio. So what is high quality? What is audio? And what is should? So is there a way that we can, one engineering requirement we could make from this? So an example that I have for you is 9 out of 10 listeners should rate the audio as high quality, and notice the quotes there, as compared to the same music played through a JBL Flip 3 Bluetooth speaker. So this is clearly measurable. It is kind of a requirement that is relying on user opinion. It is a performance requirement though. I think that's true. And I wanted to point out the use of the JBL Flip 3 Bluetooth speaker. So in this course, we're not asking you to necessarily make engineering requirements that are testable using multi-thousand or $100,000 machines. You can kind of set your standard. If you want to say that your standard is this consumer product you can purchase off the shelf and you're going to compare against that consumer product, that's fine. Just make sure it's written into your requirements and make sure you verify it by actually using that consumer product. So that's an important piece. Okay, so that's the end of our presentation about requirements. Good luck on getting your requirements entered into the system, and be specific.